Hi and welcome to video 8, I think, I've lost count a little bit, of this topic, annuities, and this is from topic 1, unit 4 of the general mathematics curriculum. So I'm going to talk a bit about the superannuation cycle in general and how it's such a great, complex, unfamiliar context, even though it's probably a bit familiar to you, but it can really be some tough questions in here. So superannuation works like this in Australia. You start work at the age of, I'm just going to say, for example, 20, and you start paying into super. Now, your plan is to retire and live off your superannuation. So you pay into super for approximately 45 years, and this is the deposit phase. You're putting in regular deposits with the plan to live off those based on starting with 0. Then you retire, and you want to live off your super. So we're now in the withdrawal phase of super, and we're going to retire for N years. N's pretty hard. It's a bit of a morbid estimation to make, but you might estimate 30 years you want to live off this, and hopefully you've got some backup plan if you live beyond that age, but that's fine. And I've written there, exercise, eat well, live stress-free, be mindful, and you will live beyond that age potentially. So let's have a look at this as a graph. In the deposit phase, our money grows like this. We're investing, it's growing as per this exponential. But as we get higher on this scale, the interest we earn gets higher, which means it gets steeper. It's pretty flat there, steeper, steeper again. Whereas in the withdrawal phase, we start high, so it starts, we're withdrawing, so we start by not losing as much. So it's quite shallow to start with because we're earning a lot of interest and then just taking a little bit down. But as we get down here, we're earning less interest, which means the withdrawals are having larger effects, and so we're better off there. Now, that's the shape of a superannuation graph. It does plummet pretty quickly at the end if you're not careful, but of course you may get to a point where something happens and you pass away and you leave a certain amount to your kids or whatever it is that you decide to do. That's the superannuation cycle. That's what it looks like. So let's have a look at one example of this, and then we'll extend that example a little bit and talk about superannuation, and then we'll finish this particular lesson. So we're talking about Altona, and Altona has planned out her life. Her plan is to work, invest $200 per fortnight into super at 8.2% per annum for 45 years. Now, time's a big thing here. If you invest in super for 30 years, it does pretty well, but 45 years, those last few years make the biggest difference. You can see it here. It's growing exponentially. You did a few more years on that, you're going to make an even bigger difference there. So you'll be surprised at the effect this has. So she's going to work for that long. She's going to retire for 25 years, live off the super fortnightly. I've chosen 8.2% because, again, that's the average profit from shares over the past however many years. So let's have a look at this. First, she's starting with 0 and she's building her money. So we're going to be dealing with A, starting with 0, annuity, M, 1 plus I to the power of N minus 1 over I. And we know that M equals $200. That's what she's depositing. I equals 8.2 over, and it's fortnightly, so 2,600. And N is equal to 45 times 26. That's how many fortnights we have, which I haven't even bothered working out. A is therefore equal to 200 times 1 plus 8.2 over 2,600 to the power of 45 times 26 over 1. Sorry about the fact I can't write things well. 8.2 over 2,600. Close brackets there. And if I put that into my calculator, it pumps out this much. 2,461,311.86 rounded. That is almost $2.5 million from that regular investment over the lifetime. And this is a pretty low value for super, but we need to keep in mind that 45-year working span is often interrupted by different things. So Altona may start working late. She might have time off. She might have children, etc., etc. So there's a few things going on. But anyway, we're going to treat that as the value. That's part 1. Part 2 is the withdrawal phase where she's living off this money. So in part 2, A is going to equal M again. This is the P equals M formula, but we're swapping P for A. And A, eventually we're going to run out of money in this withdrawal phase, so we're doing this formula here. 1 plus I to the power of negative N over I. And so this is equal to, now this time we know A is that value, and M 1 minus 1 plus 8.2 over 2600, the power of negative 25 times 26 over over I, which is 8.2 over 2600. Now, of course, this is only 25 years as opposed to the 45 years before. We have $2.5 million to live off. This is going to be pretty good. And when we do this calculation, we get M times 263.2799721. And when we divide the A value by that, M comes out as being 9348.648288. And we're going to write this down as approximately 9,348.64. I could write down 65. She kind of has 65, but if she takes out 65 cents every fortnight, she will eventually run out earlier than she expected. So let's round this one down, and there's our final value on a round down, but a withdrawal annuity, she can have that much per fortnight, which, let's be honest, is quite a lot. But super is a little bit more complex. Firstly, all super investments get taxed at $200. Altona can fix this problem by investing $230, and then the $30 disappears as tax. There are obviously also some fees, so she could also deposit the fees on top of that. A lot of people get their life insurance, TPD insurance, etc. through their super as well, so you've got to consider those fees. Rates vary, deposits vary, life situation changes, time off work, possible sick leave, maybe that insurance claim on a TPD or a disability insurance, maybe children come along, maybe you just go away for a holiday for a year. Things change. There's also inflation. So right now, $9,348 per fortnight is a lot. We're going to do pretty well. I'd be living pretty comfortable on that. But that might not be true in 45 years because inflation, which is usually about 2.5%, give or take, a little bit lower at the moment, well, that determines what money is worth and how much it's growing each year, which will deflate the value of this. And you will have heard your grandparents talk about the fact that back in their days, they could spend 5 cents at the local chippery and pick up a bag of chips weighed 3 kilograms or whatever it was that they tell you. So let's have a look at this complex unfamiliar extension. So it turns out actually Altona realizes she will need $10,000 per fortnight to live off under the situation in the previous example. How much should she be investing? Well, the trick here is this is kind of complex unfamiliar, particularly if we hadn't done the previous example. But all we're doing is we're taking this value, substituting our M in to find the A that we require, and then using the A that we require to find the M that we should be depositing as opposed to $200. So it's not that bad. So running through that process, let's have a look at how we go. We start by taking calculating our A based on the need for $10,000. And so we put it into this formula. It's the 1 minus, so we're still withdrawal phase, 1 plus 8.2 over 2,600 to the power of negative 25 times 26 over 8.2 over 2,600. And our A value, the money we require, should be a little bit more than the money we had because we were pretty close at 9,348. The money we require is 2,632,799, and then that's 0.721 ... So in 72 cents, but we don't want to round down. We require rounding up, but in this case, I'm going to maintain the accuracy. And that means that because A is equal to M times that other stuff, well, I'm going to use my A value there. M times by, and now we're doing that other annuity, which is the 1 plus the deposit phase, 2600 to the power of 45 times 26 minus 1 over 8.2, sorry, over 2600. And we get this constant multiplier, m times, well, actually, I've not determined that, but you could determine that. But we end up getting, we divide a by that multiplier, and we get 213.9346. So she's going to need 213.94. We have to round that up to make sure she has enough money at the end. So it's going to be a little bit of a bonus. You might actually be able to withdraw 10,011 cents or something per fortnight. But let's make sure we're over the 10,000 mark. So there's my final answer. It's a little bit more than what she was going to deposit. And that's good because she fell a little bit short of what we said she needed here. And really not a great deal of work needed, just some good insight and interpretation. So hopefully that means that you can now do these things. Maybe pause the video, have a look at it now. And if you're using the Cambridge text, you can move on to 9C. All the best.